All right, good morning, people. The notes for, I guess, yesterday was where you're comparing linear functions versus quadratic functions. And your linear functions, right, are your red ones and your blue function as well. Right, so your blue function is also linear. We're going to talk about the key characteristics. Okay, so from now on, whenever we are describing graphs at all, it's going to be very important to talk about the characteristics. So when I say that, you should understand it means the important details of the graph. So let's start with the red graph. The red graph, one, it's a line. That is the shape of the graph. So one of the characteristics is the shape of the graph. And for linear functions, it's a line. Okay? Another key characteristic for the red graph is that it is increasing. Okay, so it's increasing. That is the direction of the graph. So if you look at the graph, it is going upward. Okay. Other characteristics. We already talked about the domain and the range of linear functions because it covers all positive and negative x's and positive and negative y's. The domain and the range would both be all real numbers. Okay, so some things that will vary. Okay, some other important details of linear functions, right? This one, there's an x-intercept and a y-intercept. And remember, that means where they cross over the axis line. So here's the x-axis, right? So the x-intercept be nice to me. The x-intercept is this point right here. So to be -4, 0. Your y-intercept, okay, would be this point. So this would be 0, +4. Okay, so those are the important details of that linear function. So we're going to go through that again. And now we're going to do it for the blue function, which is also a linear function. Okay, because it's also still a straight line. The x value is a plain x value. So, oh, you know what? I should give you the equations. So this blue function, the equation for it is 2x plus, nope, 2x minus. 2x minus 3 is this linear function. Linear function, there's no exponent with the variable. And so the shape of it is a line. The direction, again, it's still positive. The domain and range, again, this is linear. All domain and range for linear are all real numbers. Okay. And then we have the intercepts. Sorry, I didn't write that last time. So here's an intercept where it crosses over the y, and here's an intercept where it crosses over the x. So the intercept for this blue function, let's do the y first. The y-intercept would be 0, -3. And the x-intercept, it doesn't look like it's an even point, so I think it is 1.5, 0. Okay? So those are the key characteristics for a linear function. Now we're going to move on All right, so now we are going to talk about the other two functions, the green one and the black one. So the green function, it's a quadratic function. Okay, and so, sorry about my third grade writing. Quadratic function have different characteristics than linear functions. So we're still going to talk about its shape, right? Because its shape is also still important. However, now it is no longer a line because it goes in a U shape. So it's a U-shaped, which instead of a line is a curve. And the curve is called a parabola. I like to say parabola because that's how it's spelled, parabola, but it's a parabola. The direction, so it has two different directions because it's not just a straight line going in one direction. So here, right, if I was saying like this was a ball, the ball would be going down and then the ball would be going up. So it changes directions. So it decreases going down from all the way to the end. So again, this doesn't stop, right? It just keeps going. So it goes all the way back down to negative infinity. And then it decreases all the way till it gets to 0. And now from 0 all the way to positive infinity, right? So now it's going to increase from 0 all the way to positive infinity. Okay, so it decreases and then it increases. The next thing we can talk about is the key point in a quadratic. They're very different. So you have this middle point, okay, which is always, always, always on every quadratic. This middle point is always called the vertex. The vertex is always the center of a quadratic. It's always the minimum or the maximum. Okay, for this graph, it's the lowest point. So it's the minimum. So for this graph, our vertex, which is our center point, is going to be our minimum. And that point is at 0, 0. It is not always at 0, 0. It just is for this graph. Also for this graph, both our x-intercept and our y-intercept are both at 0, 0. Okay? So, what also is important on these graphs, right, is this thing in the middle. It's an imaginary line that goes down the center. This imaginary line that goes down the center, we abbreviate AOS, but it's called the axis of symmetry. The axis of symmetry. And it's always going to be the x value of the vertex. Okay? This is that imaginary line that goes down the center. And it splits the graph in half. So that every point, so if we make up a point over here, has the exact same point on the other side. Okay? That point is called an image. So P's image. Okay? So we're going to do this again. With the black graph. So the black graph is a little bit different, right? Here's the equation for the black graph. It's still a quadratic. If you remember, if I could spell it right. If you remember, we talked about inside change and outside change. This negative sign means reflection. So this one was going upward. The black graph is going downward. Also, this positive 6, right? Remember, inside change is opposite, so it's going to go backwards 6. So it shifts everything from positive to negative, and then it shifts that 6 over backwards, right? So the shape of the graph is still a parabola. The direction, right? So this graph is going to go increase and then it's going to decrease. So it increases from negative infinity to 0 because it's on the y. And then it decreases now. From 0 to positive infinity. Sorry. Okay. Then let's talk about the vertex. Okay, that's middle point. So the vertex is that middle point. It is going to be the maximum because it's the highest point on the black graph. And the point itself is going to be -6, 0. The axis of symmetry, remember it's this imaginary line that goes down the center, right? So the axis of symmetry is going to be x equals -6 because it's the x value of the vertex and it goes down the center. Both the intercepts, right? Oh, you can't see the y-intercept for this graph. That sucks. Sorry, it is at 10. Can't see it in the view of this. So the x-intercept, here's the x-intercept. It is at 0. The y-intercept, however, you can't see it on this graph, but it's down there. There is one down there. Okay? So those are the important details. Now I do want to show you one more type of graph for quadratic so that you can see, because this is missing something. So another type of x graph . All right, here we go. So this graph is a little bit different. It's not going to let me write on it, so you just have to pay attention to my words. Here's the vertex, right? So this vertex, here's the vertex. It's the lowest point, so it's the minimum, okay? And the point is 1, 8. This point is our y-intercept. It's where it crosses over the y-axis, 0, -7. However, the difference with this graph is it has 2 x-intercepts. The decimals count as numbers, okay? So use those. But it has 2 x-intercepts. That's what's very important about the graph. So a lot of times your parabolas are going to have 2 x-intercepts, not just 1. Okay? So here's your characteristics for a quadratic. Go.